Hello everyone. In this video, we are trying to explain the term heteroscadasticity. Before explaining heteroscadasticity, I would like to introduce the term homoscadasticity. A critical assumption of the classical linear regression model is that the error terms is constant across all the observations. This condition is known as homoscadasticity, whereas on the other hand, the error terms are varying and that condition is known as heteroscadasticity. In the given equation of the regression model, ui represents the error terms. The condition of homoscadasticity states that variance of ui equal to sigma square is constant across all the observations in the model, and heteroscadasticity states that variance of ui varies across the observations of the model. The reasons for heteroscadasticity may be the presence of outliers in the data, incorrect functional form of the regression model, and maybe incorrect transformation of data. So in short, heteroscadasticity is a systematic pattern in the errors where the variance of the error are not constant. It occurs when the variance of the error term differ across observation.
So here we can see a graph. So here we have taken the consumption and the income, consumption of the poor and the rich. So here, if for example, if we take homoscedasticity pattern of an error, then if you come across, we can see about the heteroscedasticity pattern of errors. So again, we have taken on the y-axis the consumption and on the x-axis the income. Now let's come across the heteroscedasticity versus discrete heteroscedasticity. So if we talk about heteroscedasticity, the scatter of the residual around the regression line is the same for all the values of the predictor. And for the discrete heteroscedasticity, on the other hand, occurs when the variance of the error is not constant, but varies symmetrically based on the level of discrete predictor variable. This can happen when there are groups or categories within the predictor variable that have different level of variability.
Now, I will explain about the consequences of using OLS in the presence of heteroscadasticity. There are at least three consequences for using OLS in the presence of heteroscadasticity. They are: OLS estimators still gives unbiased coefficient estimates, but they are no longer blue. That implies that if we still use OLS in the presence of heteroscadasticity, our standard errors could be inappropriate and hence our inferences could be very misleading. The second point is that whether the standard errors calculated using the usual formula are too big or too small will depend upon the form of heteroscadasticity. In the presence of heteroscadasticity, the variances of OLS estimators are not provided by the usual OLS formulas. But if we persist in using the OLS formulas as usual, the t-test and the f-test based on the can be highly misleading, resulting in erroneous conclusions. Now, we have learned from this video that one of the assumptions of OLS regression is that error terms have a constraint variance across all values of independent variables. With heteroscedasticity, this error term variance is not constant, and this is more common in cross-sectional data than in time series data. Even if heteroscedasticity is present or suspended, whatever conclusions we draw or inferences we find may be very misleading. Thank you.